Hello, everyone. We're going to continue on with our learning about renewable energy sources, and today we're going to learn about wind, water, and geothermal energy. So last time we learned about solar energy, and that was enough to fill a whole day. These ones take less time, so we'll be able to get through them. Now, before we get to that, I want to say one quick thing about um, solar reflector farms. This came up last time, and I saw when you guys were answering your questions on the Google form, a lot of people were a little bit confused about this one. The major advantage of solar reflector farms, there was a question about what are the advantages. The number one advantage of solar reflector farms is that they produce electricity round the clock. They don't depend on just the sun shining on them like photovoltaic cells do. Uh, with photovoltaic cells, when the sun stops shining at nighttime, when it goes beyond a cloud, you don't get electricity anymore. But solar reflector farms, they make electricity all the time because they're heating up that big pool of molten salt at the top of that tower, turning it basically into lava, and that stuff stays hot through the entire night. It absorbs enough energy to keep the water boiling and the turbines spinning all through the night. So that's the advantage of solar farms. They work round the clock, and you can get electricity from them anytime that you need them. The disadvantage is that you have to put them someplace where the sun shines most of the time. So that limits them basically to desert environments because they're not compatible with farmland. You can't grow lettuce or something underneath the shadow of these mirrors. Um, and you can't, they're not so useful in places where it's cloudy a lot. So they're best out in the desert, but when you have a good place for them, they produce electricity around the clock. Okay, let's get on to what we have today. Wind, water, and geothermal energy. Once again, you need to know what each one is. You need to know where the energy originally came from for each one of these, and how we get the energy from the source. So how the energy went into the source and how we get the energy out of the source. And finally, of course, you got to know the advantages and disadvantages of each one. So let's start off with wind. That'll be the first one. So this is like windmills. You've seen windmills around. They're becoming more and more popular. Um, so it's energy taken from the wind. Now, why does the wind blow? And this is something you're going to recognize from the past. The wind blows because of convection currents in the atmosphere that are driven by the sun. This is a rather simple diagram of it, but the idea is that the equator gets more sunlight per square meter than the polar regions do, which means that the equator is warmer, heats up the air more, and the warm air rises. And then that warm air travels to cooler regions where it's cold, and then it descends, and you have a convection current. Rising where it's warm from below and descending where it's cooler. So it transports heat from low to high. And this motion of the air we perceive as wind. Now, I said this is a kind of an oversimplified diagram because this just shows the air rising at the equator and descending at the poles. In reality, our Earth is actually split up into about three bands north of the equator and three bands south of the equator. So air does rise at the equator, but it descends about a third of the way up toward the North Pole. And then um, so where we live, the air actually the wind generally blows from west to east, um, and at the equator it blows from east to west. And then if you get up toward the poles, it again blows from east to west. And it has to do with the Coriolis effect. And the point is, it's a little bit more complex than just this first simple diagram that I showed you. But the concept is the same. Our major wind patterns are driven by convection currents, which are powered by the sun. So ultimately, wind energy comes from the sun. Okay, how do we make use of it? Well, remember this. This was the coal-fired plant, and the question about how we generate electricity is how we spin the generator. And the way we do it in a coal-fired plant is we drive steam through a turbine. And that is usually the technical hurdle for all these ways we generate electricity, is how do you spin the turbine? And then you connect a generator to the turbine and make electricity. Well, with a windmill, the blades are the turbine. You have the wind blowing across those blades and spins the blades. So this housing back here holds the generator. This makes windmills very efficient and very simple because you don't have to have any of this other machinery and equipment to boil water and transport it around and cool it and do all that stuff. You just have the wind blowing directly across the turbine and the turbine spinning a generator, and there you are. So yeah, very simple design, very efficient. And that's how we get energy from the wind. We connect the wind turbine directly to a generator. Okay, like everything, there are advantages and disadvantages. What's good about wind energy? First off, there's lots of wind in the world. According to some sources, there's 10 times as much energy in wind, 10 times what we actually need to run our civilization. So, yeah, there's really no upper limit to how much energy we could get from the wind. It theoretically could provide all that we need. Um, Also, the wind blows for free. It's completely renewable and sustainable, and the wind blowing does not pollute the atmosphere or contribute to global warming. So, this is clean and it's efficient, it's renewable, it's sustainable, and these are all good things. Another nice thing about windmills is that you can build them in farmers' fields. And you see this a lot if you drive across the country or drive through Pennsylvania or something like that. Windmills don't cast a very large shadow. So you can plant them in the middle of a cornfield or a cotton field or something, and the plants around them will grow just fine because the sun shines on those plants most of the time. As the sun moves across the sky, the shadow of the windmill moves. So the plants get all the sunlight they need, and you can put these in farmers' fields. They're compatible with other land uses, and that's a very good thing. Okay, what's bad about wind energy? Surprisingly, there are some bad things you may not have thought of. First of all, the wind doesn't blow all the time. So again, this doesn't necessarily provide electricity when you need it. It provides electricity when it feels like it. And that means that you have to have either some way to store the electricity, which means batteries, which means you become a lot less efficient, or you have to build a lot more windmills than you need so that you do have enough electricity when you do need it. And that's very inefficient because it gets expensive and you have all these windmills that are not being used. Or you have to have another energy source to fill the gaps. So, yeah, the wind doesn't blow all the time, and that is a serious, significant drawback to wind energy. What it means is that wind is a piece of our energy puzzle. It is not the entire solution by itself. Okay, another problem with windmills is that they are really loud. You generally see these things in the distance and you can't hear them. But if you ever get out of your car and go stand next to one of these things sound like an airplane coming in for landing. And it's because the blades are moving so fast. The tips of those blades move at over 100 miles an hour, way over 100 miles an hour. Usually it's upward of 200 miles per hour. So this is like an airplane flying at high speed, and you can hear the wind flowing over those wingtips. If you've ever been to an airport and you've watched airplanes land, they make a very high pitched screeching whine even when they're coming in for a landing. And that's not the jet engines, that's actually the sound of the air rolling over the wings and spinning off the wingtips. And you get the same thing off the tips of the blades in windmills, which makes them really loud. If you have one of these big ones next to your house, you're basically listening to airplanes flying over your house all the time. And people don't like that. So this is why we don't see windmills planted in the middle of cities and towns. We put them out in the countryside or out off our coasts so that people don't have to deal with the sound. Also, some people think that they're ugly. There's a it's called the NIMBY concept, NIMBY, not in my backyard. People don't want to see these things. So people with expensive beach houses and beautiful ocean views don't want to have to look at these things. Um, this has been a gigantic objection to them. So there was proposals to build wind farms near Martha's Vineyard and in Cape Cod, but the rich people with beach houses didn't want to have to look at the windmills all the time, and they said, "No, you build them someplace else." Well, guess what? Beachfront property is expensive and valuable pretty much everywhere in the United States, which means that people everywhere on the coast object to the or wind farms, offshore wind farms are objected to everywhere. Now, I personally think that people would get used to these. There was an ironic thing um, about it was a letter to an editor, which I saw at one point. where this person was complaining about seeing the windmills out on the in the ocean and interfering with their view of sailboats sailing by. Well, what's ironic about this? Because sailboats are also wind-powered technological devices, but we're used to sailboats, and we think that they're beautiful as they sail along. Well, as time passes, people might get used to this and find the motion of windmills soothing. Who knows? But yeah, there's some objection to them because they're new and they're different, and people think they spoil their view. Oh well, that's how it is. Life is full of trade-offs. What else is bad about wind energy? They kill large numbers of birds and bats. Birds and bats have not evolved to perceive how fast these blades are going. Yeah, they do see them moving, but they fly right through the path of these blades, and they don't realize that they're coming toward them at hundreds of miles an hour. And so they get hit and they get killed. And these windmill farms are littered with dead birds and dead bats, particularly during bird migration season, because birds that live in the area of the windmills, they kind of figure it out. They kind of get used to it. They avoid them. But birds that are just flying through, passing through, they have no idea. And they get hit in large numbers. This is another kind of an ironic thing, or unexpected results or unexpected consequences. A long time ago, the Audubon Society and the Sierra Club, which are two major environmental groups, were heavily in favor of windmill farms because they were non-polluting. They don't contribute to global warming. They don't contribute to acid rain. That was a bigger deal at the time. They're sustainable. What's not to like? But now they've done a complete 180, especially the Audubon Society, which supports bird populations, natural bird populations, and has put a lot of pressure on Congress and regulatory agencies to find some way to protect birds from these windmills. Um, I saw one recently on a Nova that they just hit on PBS, the program Nova, this week put out an episode on eagles, and it showed a short bit about a system in a windmill farm that has cameras and artificial intelligence. These cameras look everywhere and are able to recognize eagles and where eagles are and where they're flying. And if the AI is able to project that an eagle is going to fly through the path of one of the windmills in the windmill farm, the system shuts down that windmill until the eagle flies through the path, and then it starts up the windmill again. Now that's kind of expensive. That puts a lot of wear and tear on the windmill, but that's what's necessary to save these endangered species. So that's where we are. Okay, moving along. Um, There's also a lot of toxic waste that is produced during the manufacture of of the windmills. Um, the blades are like 150, 200 feet long. These things are gigantic. They're like airplane wings, as I said before. And a lot of them are made of composite materials, which involves carbon fiber or fiberglass or other materials, and then these exotic plastics and epoxies that have to be molded and shaped. And yeah, there's a lot of toxic waste that goes into making these exotic materials. Um, Now, we don't build a lot of windmills in the United States. We let the Chinese do that. And it's sort of like the solar panels that we talked about last time. We pat ourselves on the back about how environmentally responsible we are for getting our energy from windmills. And we conveniently forget the amount of toxic waste and environmental damage which is done in China in putting these things together. So, in effect, we have exported the pollution to another country. Now, again, China is getting wealthy enough, and their standard of living is getting high enough that the people are starting to object to this, and their environmental regulations are increasing rapidly in China. So we may find windmill blades being made in the United States again. The cost will go up because we have to take care of that toxic waste and take the environmental consequences into account. Now, it's not just the blades; it's also the magnets. Remember, the way we generate electricity is by spinning magnets around wires to drive electrons through those wires. So, and we want to make these generators that are in the windmills, we want to make them as small and lightweight as possible. And that means making very, very strong, very powerful magnets.